The sum of the first n odd natural numbers is always n squared. Hey, what's up everyone? Welcome to another episode of Christian Relearns Math, where today we're going to go over the intuition for why that is true. So first, let's remember what natural numbers are, and all natural numbers means is that we're talking about integers, positive integers specifically, and we're talking about a sum of a series of positive integers. So natural numbers, so we're starting at 1. We're interested in odd natural numbers, okay, so not interested in the even ones. And then we're looking at a series of them, okay, so it could be, for example, 1, 3, and 5. That would be the first 3 natural numbers. Okay, cool. So let's then think about that. So if we have, let's say, 1, and then we have 3, and then we have 5. This would be the sum of the first 3 odd natural numbers. Okay, so if we perform that calculation, we get 6 and 3 is 9. Okay, this is one way to represent this equality, this equation, but it's not the only way we can represent this. Remember that we can also represent this visually. So for example, if we, instead of using Arabic numerals here to represent this, what if we represented them as unit squares? So that's our 1 unit square, and then we're adding 3 unit squares, okay, and then here we're adding 5 unit squares. Okay, how does this help us? How is this useful here? In our visual representation here, we stacked all the unit squares on top of each other in a straight line. Okay, but that's not the only way we can represent them. Let's focus in on this 3, on this representation of a quantity of 3. Okay, we can also represent this as, could do it horizontally. Okay, we'd have it vertically there, but we have 3 of them. We can also do something like this. Okay, and we could rotate that shape. We could have things like that. What do these kind of look like? If we consider it for a minute, these kind of look like squares, except they're missing a piece. And specifically, they look like squares with a side length of 2, and they're missing 1 piece. We're adding that quantity 3 to 1 piece, 1 unit square. So if we add in the unit square that we're missing, what does that leave us with? It leaves us with a complete square of side length 2. So only focusing in on the 1 and 3 for now, if we change how we represent this 3, we realize that this 1 and 3 together gives us a square of side length 2. And notice for these, for only this case here, we have, this is the first 2 odd natural numbers. And it gives us a square made up of unit squares of side length 2. So we have a total of 4 unit squares. That's kind of neat. Now let's consider the 5 that we added in here. What happens there? Okay, so we have our 1 square, and then we added our 3 squares from our second natural number, and then we have our 5. Okay, so we have 1, 2, 3, 4, 5. Look at that. So our third odd natural number gives us a square of side length 3, consisting of 9 unit squares. That's pretty cool. So we seem to have a pattern here, but the thing is this pattern going to hold up for all series in this? What if our series goes on for quite a long time? Are we always going to get a nice square like that? So one way we can think about this is to really consider what's the change from one odd natural number to the next odd natural number. So here we have 1, then 3, then 5. What did we do to get from 1 to 3? Well, we added 2. And Do we have to add 2? Is that the only way we can get to the next odd natural number? So we're dealing with natural numbers, so that means we're dealing with this series of numbers, and we're only considering odd ones, which means if we start at 1, well, our only options are to go to 2 or to go to 3. 2 is not an odd number, which means that to get to the next natural number, it's 3. So we have to add 2 to it. We have to get to 3. Okay, so now if we're at 3, what can we go to? Well, we're only concerned with odd numbers, so we can't get to 4, and then the next option after that is 5, which is an odd number. And how did we get there? Well, same way we got from 1 to 3. We added 2. We added 2. Okay, now if we're at 5, how do we get to the next one? Well, 6 is even. Get to the next one? 7. 7 is our next option. 7 is odd. We add 2. So we're always going to add 2 to get to our next odd natural number. And more specifically, when we're adding 7 here, recognize that what we're adding is the number that we were just at, so in this example 5, and then our 2, our common difference of 2. So here, when we're adding 7, if we think about this visually, what we can see is that we have our layer of 5, and we can see here we've colored them in, right? So we have our first layer of 1, there's our square, then our second layer of 3, there's our blue layer, our third layer of 5, there's our green layer, and you can see they sort of make these chevron, these carrot shapes that we keep adding to the square. So when we want to add our next odd natural number of 7, what's that going to do? Well, watch this. We can take our shape, we can take our chevron, and then we're copying the previous number, that's our 5, okay, and then what's the common difference from our previous odd number to our next odd natural number? Well, it's 2. It's these spaces here. And we still have our square. Now we've gone ahead and added our colors in here, but you can see that we still get that chevron pattern. We still get that carrot, that L shape, and we still end up with a square. And this is how many natural numbers do we have? How many natural numbers are we summing here? We're summing the first 4 odd natural numbers. Our square has sides of length 4. Let's do one more. So if we add 9, so we'll add 9 here. And remember, to get from 7 to 9, what is that? Well, we added the one that we had plus our difference, our common difference of 2 to get from one odd natural number to the next. The same thing visually, we can duplicate our previous layer, add that in, and then we add in our common difference to go from one odd natural number to the next. And you can see we still get our square. And how many natural numbers do we have now? Well, now we have 5. Our square of side length 5. Now we've gone ahead and added the colors for that layer, and you can see here that we have our first 5 odd natural numbers, there they are, and our square here has side lengths of 5, which means that the total number of squares in this is 5 squared, or n squared. So that's the intuition for why the sum of the first n odd natural numbers is always n squared. So I hope you found that visualization helpful. I know I certainly do. Make sure to like, comment, subscribe, all that good stuff. Share it with a friend too who needs to see it. I hope you have a wonderful day, and I will see you next time. Bye!